Thank you very much for that very generous introduction. I will share my screen now. Okay, I am very honored and pleased to be a speaker in this very impressive series. And I will start out by mentioning something about Rachel Carson, who certainly was remarkably influential in terms of her books, especially the two that I've highlighted here, The Sea Around Us, which alerted many people to the amazing aspects of the oceans, the world's oceans, and then Silent Spring that Jack has already mentioned, and that had a huge impact by all that she showed, an example after example after example of the damage that insecticides and pesticides and herbicides have had on the world and on humans and on species, other species. Rachel Carson was living in a time when it was becoming apparent that the industrialization of the world had some very negative consequences. And I show these two pictures as good illustrations of how bad the pollution was becoming. The one on the left is a smog event in Donera, Pennsylvania in 1948. Both of these pictures are daytime pictures, which is remarkable how they look because of this pollution aspect. In Donera, Pennsylvania, roughly half the people got sick from this pollution episode, and estimates are that 20 to 40 people died. 4 years later, a much bigger community, London, one of the largest cities in the world, got a similar pollution event. And both of these events were caused by the pollution that humans are putting into the atmosphere, and also the specific weather conditions at the time and the geography of the locations. So these were similar events. In the London case, and estimates are that 40,000 people died in just 4 days, 40,000 people. This is something that clearly can't be ignored, especially in London, which is the seat of Parliament. So Parliament couldn't ignore 40,000 people dying. And indeed, the British did come out with a Clean Air Act in 1956. And then this was followed by Clean Air Acts from many different countries. This list is by no means complete, but it is showing some significant legislation resulting from knowledge that pollution was causing problems. And so in the US, 1963, very important Clean Air Act. It was further strengthened in 1970. There had been some Clean Air Acts before this, but not as important as the 1963 one. But there were other things going on in the 1960s and 1950s also, not just air pollution. There were things like in the picture in the upper right, an oil spill. Major oil spills were happening. The picture in the center bottom, rivers actually caught on fire because of the industrial pollution being accessed into rivers. And this is the 1952 picture is the Cuyahoga River, which caught on fire many different times, including again in 1969, although that was not as big a fire as the 1952 one. Rachel Carson's book was certainly an important aspect of raising awareness of environmental issues. And another book was The Population Bomb by Paul Ehrlich and his wife, Anne Ehrlich. The Population Bomb was not just about population, but it was also about what humans are doing to the environment. So that was another really important one. And then the photographs coming out from space, from NASA's Apollo program, those also alerted humans to the fragility of our planet against the black darkness of space and how thin the atmosphere is. So all these types of things raised awareness of environmental issues. And then on April 22nd, 1970, the first Earth Day came about. Lots of times the first of something, things start kind of small. The first Earth Day, 20 million people were out in celebration of the earth and concern about what humans are doing to it. So, I mean, this started out with a huge bang. So the first Earth Day, 1970, and then by the end of 1970, December 2nd, the Environmental Protection Agency, the EPA, was formed. Then throughout the 70s, there were all sorts of environmental and related legislation. The Clean Air in 1970, Occupational Safety and Health Act, Clean Water Act, Marine Mammal Protection Act, Endangered Species Act, Toxic Substances Control Act, Surface Mining Control and Reclamation Act, and the Clean Air Act amendments. All of these were very much bipartisan. The first Earth Day was founded by a Democratic senator from Wisconsin, Gaylord Nelson. EPA was started by a Republican president, Richard Nixon, and Nixon started the EPA not by signing something that Congress did, but by executive order. So all of this concern about the environment raised by Rachel Carson and others did result in all sorts of legislation that certainly has improved things for us. Now, nothing's perfect. A lot more environmental problems keep arising, but they would be worse if we didn't have these legislative things. In the 1970s also, people became concerned about what might humans be doing to the upper atmosphere, the stratosphere, and in particular, the layer in the stratosphere called the ozone layer. The ozone layer helps protect life at the Earth's surface because of restricting the ultraviolet radiation from the sun from getting down to the surface. And so people were concerned, could humans be affecting the ozone layer also? And in 1985, the British at their station in Antarctica, the Haley Base Station, they saw decreases in ozone quickly confirmed for the entire Antarctic region by satellite data. And 2 years later, only 2 years after the first limits of ozone were found, 2 years later, the international community came up with the Montreal Protocol. This is amazingly fast to have the international community come out and sign something because of concern about, in this case, the upper atmosphere. Well, the concern was that we humans and other species would be harmed if this ozone layer were decreased. So the plots on the bottom show the effect of the Montreal Protocol. The ozone area quickly stopped getting larger, and the ozone hole depth quickly stopped getting deeper. So things are not back to what they had been in the 1970s, but at least the huge damage occurring to the ozone hole has at least leveled off, or somewhat leveled off. So now, with those examples of effective actions being taken um, regarding pollution and stratospheric ozone depletion. Now I'm going to turn to the climate change issue, where most of us in the climate change community really would like more effective actions to be taken than what has been taken so far. So first, some basic background. Basic background is that there are gases in the atmosphere that allow the sun's radiation to get through to the Earth surface, but hinder the Earth's radiation from getting out. These are termed greenhouse gases. The three most abundant are water vapor first, then carbon dioxide, and then methane. Greenhouse gases will have a tendency to increase the temperature of the lower atmosphere because of this fact that they're letting the sun's radiation in and hindering some of the Earth's radiation from getting out. Human activities are definitely increasing the level of greenhouse gases in the atmosphere. So this stimulates warming. Other human activities don't stimulate warming. Some stimulate cooling, but model simulations indicate that the warming coming from the increased greenhouse gases outweighs the cooling that comes from some of the other activities of humans, and that this warming could lead to levels that are really badly damaging to humans and others. Warming itself doesn't sound so bad, but when you look at the consequences of warming, there are lots of consequences of warming. More severe heat waves. If warming continues, you've got permafrost decaying. That can be a problem. You've got, loss of sea ice, which is a problem for polar bears. A lot of people might say loss of sea ice is not so bad for us, but the loss of land ice, if land ice decays, that water ends up going into the oceans, and you've got sea level rise, which produces coastal erosion. Lots of species have to adjust. Some will end up going extinct. Warming also means that the likelihood is that tropical diseases will spread poleward, coral bleaching, lots of problems resulting. And so now look at why has there not been as much success as there was in the 1960s and 1970s regarding the environmental issues raised by Rachel Carson and others. So first of all, many people feel that the case against the climate changes that humans are producing is really, it's not a compelling case. And first of all, it's just not so scary to say that it's going to be warmer by 2 degrees. All of us experience warming much greater than that just in the normal course of a day. So it's just not scary, like 4,000 people died in London in 4 days because of a smog incident. And it's not scary like Rachel Carson's examples of dead birds scattering over estates, or dead fish floating down rivers, or foxes dazed and running around in circles until they collapse and die. So it's just not scary like the pollution issues were, and still are in some cases. And next one is that there haven't been any horrendous episodes that people could say they are definitely caused by human-caused climate change. And next is that there are some positives as well as negative consequences of the anticipated warming. there should be fewer deaths by freezing. So that's a positive. Agriculture and some high latitude regions, you could have agriculture in regions that don't support agriculture now. There's certainly some positives as well as negatives. And then also the very real fact that the models that are predicting the bad conditions, those models aren't perfect. All of our models were created by humans. They're imperfect. They don't have the full complexity of the actual climate system. And so all those reasons are reasons why the case is not considered compelling by some people. And those are valid reasons. And then also there's the expense. The expense of going away from fossil fuels is a major expense. It's less now as people are getting alternative energies to be priced cheaper and cheaper. So the expense issue is getting lessened. But the next bullet, the need to allow developing nations to develop. It's just totally unfair if developed nations now say to nations that are not fully developed yet, your people can't have refrigerators or washing machines or other things that might be emitting greenhouse gases. You've got to allow developing nations to develop. So all of those are serious problems. But another set of problems comes because of how the case is being presented. And so I've got a lot more slides to deal with this. People are making the case too dogmatically, often too one-sided, too many exaggerations, and too much nastiness toward the people who disagree. And as a result, the discussion has become overly polarized, hindering the dissemination of a balanced picture. So this next slide shows some specific types of troublesome statements. Things like people saying, we're raising greenhouse gases to levels higher than they've ever been, or the atmosphere is warmer than it's ever been, or sea levels are rising faster than ever before, or all glaciers are retreating. None of those is a true statement. And yet they sometimes are coming out in terms of what people in the so-called mainstream on climate change issues are saying. They are not true. And I'll get into that a little bit more in the next few slides. And it's really damaging to be saying untrue statements because they can be countered, and then the discussion becomes a battle and very confrontational instead of a more reasoned scientific discussion. And then similarly, placards. I've seen placards at protests saying, stop climate change. Well, this is reflective of just not understanding the Earth's evolution. I mean, climate change has been going on for 4.5 billion years. We're not going to be stopping climate change. So it's just not realistic. And on the right side, I've got a very specific case because it happens to be a case concerning sea ice, which is where my expertise is. And it's a case where I was involved in trying to clarify things. And so the quote that came out in the New York Times back in 2000, after a ship went up to the North Pole and there was open water there, and this was considered remarkable. And the New York Times printed that the last time scientists can be certain the pole was awash in water was more than 50 million years ago. Well, that is absurd. And the reality is the sea ice in the Arctic is floating around. It's not land ice, it's floating. And so there are breaks between the ice flows. And so every summer you can expect that there'll be several occasions when right at the pole, it's going to be a break between ice flows instead of the ice itself. So fortunately, the New York Times author quickly heard that this statement was absurd, and he did call me and other sea ice experts and got it clarified that no, this is not a good statement. And he did 10 days after the initial New York Times article, he did correct it with an article titled "Open Water at Pole is Not Surprising," experts say. So that case, though, does illustrate that even really well-regarded and very accomplished people and organizations, whether the person on the ship who alerted the New York Times to these unusual conditions was a professor from Harvard who is an expert in climate, just not in sea ice. So you can have very accomplished people and very accomplished organizations saying things that are really quite out of line with reality. And so because of that, the next 3 slides, I'm going to give some indications of the long-term history, just so that the people in the audience will not be making the kinds of mistakes that the previous slide showed. So the Earth's long-term history clearly is not known precisely. Certainly, expectation is that as time goes on, the details will be adjusted as they have been in the last few decades. But it's thought that the Earth probably formed about 4.6 billion years ago, and that likely the early atmosphere was what was coming out of volcanoes, and likely what was coming out of volcanoes was close to what comes out today, in which case likely the atmosphere in the early Earth was dominated by water vapor, and the next most important gas was likely carbon dioxide, and probably almost no oxygen, almost no nitrogen. You look at today, the atmosphere is dominated by nitrogen. The next most is oxygen, and there's very little water vapor or carbon dioxide. So it took billions of years, but the atmosphere changed dramatically in those billions of years. So the people who say carbon dioxide levels are getting higher than they've ever been, I mean, that's just so far off, because carbon dioxide was so much greater back earlier in Earth's history. This just shows another type of illustration of why climates were very different in the past than today. This is the U.S. Geological Survey's estimates of where the continents were about 200 million years ago on the left picture, and about 65 million years ago on the right picture. And on the left picture, if you look at it, those of you who are familiar with the impact of the Gulf Stream on the climate in Northern Europe will look at this picture and be aware that, hey, there's no Gulf Stream because there's no open Atlantic Ocean 200 million years ago. And so clearly the climate's going to have to be way, way different. And on the right-hand picture, there's a large island in what's now the Indian Ocean. So if you look at that island and then you look at the left picture, you can see that that island actually slowly moved upward from it had been down at the attached to Antarctica and Australia. So it moved upward, and that right-hand picture is repeated on this slide. And here I've got an arrow now indicating where that island went. So that island ended up colliding into Asia, and now it's essentially close to, it's India. It's basically what we now consider India. So, but when it collided into Asia, it produced the Himalayan mountain range and the Tibetan plateau. This was a lot of rock coming up to the surface and undergoing, over millions of years, undergoing rock weathering. Now, rock weathering can be mechanical, it can also be chemical, and the chemical rock weathering takes carbon dioxide out of the atmosphere and therefore leads to a cooling. And the estimates are that this collision started about 50 million years ago, that at that time, carbon dioxide levels in the atmosphere were about 1,600 parts per million, i.e. roughly 4 times what they are now. So carbon dioxide amounts were way higher. And then bit by bit, they decreased as this rock weathering was taking place over millions of years and got colder and colder. And it's thought that before 50 million years ago, there was likely, in the previous hundreds million years or so, there was likely very little ice on the Earth at all. But by 34 million years ago, it had cooled down enough that the Antarctic ice sheet started forming. And then by about a million years or a few million years ago, ice started forming on Greenland. So all of these are illustrations of the fact that climate changes for many different reasons, plate tectonics being sort of the driving force behind the continental drift that I've been discussing. And once it got down cold enough so that there was ice in the North Polar region, then you start getting the Earth's orbital changes to lead to the sequence of ice ages that we've had in the past million years, where there's an ice age and then less and then more and then less. Asteroids also are causes of climate change, and the big one most people have heard of would be 65 million years ago at the end of the reign of the dinosaurs, and then volcanic eruptions. And now, in the past geologically short time frame, humans are additional causes of climate change. Agriculture, which started about 10,000 years ago, and the industrialization that has really spurred on human impacts in the last 200 years. So those are the basics of the long-term history of the Earth. But now let's look at the past few decades. And upper left plot is the atmospheric carbon dioxide at Mauna Loa in Hawaii. And you could see that that's just been increasing year after year after year. There's a seasonal cycle, an annual cycle in it, but every year it's higher carbon dioxide than before. And that's largely from human activities. The lower left is the methane amounts. Latitude is the y-axis. If you go across the latitudes, any latitude line, you'll see that the trend is toward more methane. And then the upper right picture is temperatures. And you can see that the trend is upward on the temperatures too. It's not nearly as uniform as the increases in carbon dioxide, but it's clearly an upward trend in the temperatures. And the fact that it's not uniform is just reflective of the fact that there are many causes of climate change. Carbon dioxide is certainly not the unique one. And then the bottom right picture shows the annual temperature average for 2023 versus the average in the years 1951 to 1980. And you could see that the reds, which are the highest warming, the Arctic has a lot of reds, and people expected that. And part of the reason, a large part of the reason, is because of ice. Ice is very reflective. So if there's a lot of ice and the sun's radiation is coming down, a lot of that sun's radiation is going to get reflected off, go back to space. If the ice is removed and the sun's radiation doesn't get reflected off, instead it goes into the oceans, then you're going to warm up the system further. And so the expectation was that this feedback of warming, producing more warming, this so-called positive feedback, is a reason why people expected the Arctic to indeed have greater warming than most of the rest of the world. And here's a plot of Arctic sea ice extents from the satellite record starting in 1979, going, and you can see that there's huge contrast, way more ice in the winter than the summer, but you could pick any month and the trend is downward. And that's clear by looking at the bottom months, which are September. I mean, clearly a downward trend, and clearly a downward trend in the winter too, and the peaks. So the Arctic fit really well with the expectations of less sea ice, more warming. The Antarctic situation did not fit as well. The expectation in general was that the Antarctic sea ice would also decrease, and it didn't for several decades. And then finally in 2014, a huge decrease. I put this up to just make it clear that here's a case which is kind of a microcosm of the climate change situation at large, in terms of there might be huge support for what was expected, as the Arctic results show, but not everything is going to match what was expected. When one speaks of global warming, that means the average for the globe. It doesn't mean every single point is going to be having a warming. It's the average for the globe. And so the Antarctic is just one case where it wasn't doing what was expected. And then in 2014 to 2017, the huge decrease was way greater decrease than what the Arctic had experienced in any comparable number of years. And so the Antarctic case remains puzzling for many scientists. There's no consensus yet on why the Antarctic went the way it did. And even in the Arctic case, the predictions weren't perfect. The predictions from the models, and this is a plot from a great plot from Julian Struve and her colleagues, published back in 2007, showing 13 different global climate models, their predictions of what would happen to the sea ice. And then in red, it shows what actually did happen. And all the models got it right in terms of decreasing sea ice coverage. So great. All the models, all 13 models got it right. None of them got it as fast as what happened. So this is illustrative that the models are good, but not perfect. And some people will say, well, sea ice, yeah, it affects polar bears, but and it might affect our mid-latitude weather a bit, but they might not be totally convinced that it really matters to them. Well, ice sheets is a different problem. When the ice sheets decay, sea level rises, humans have built so much infrastructure along coasts that this does matter directly. So here are satellite data showing decay in the Antarctic ice sheet mass, decay in the Greenland ice sheet mass, and indeed the rise in sea levels. The sea level rise here is nowhere near as fast as it was at the decay of the major ice sheets at the end of the last ice age. So it's nowhere near as fast. So comments that it's faster than ever before are just way out of line. However, it's rising, and that's what's important to humans. I mean, with rising sea levels, you've got islands that are going underwater. You've got all sorts of problems. So the fact that it wasn't as fast as in the past doesn't lessen the fact that it can be really damaging today. The fact, the importance of knowing that it's not as fast as it was in the past is so that you won't make mistakes and then get into scientific arguments over that. So it's not as fast, but it still can be hugely important for humans, as can lots of the other changes that are happening. Expect permafrost to decay and all sorts of infrastructure problems there, all sorts of additional problems like ocean acidification from the more carbon dioxide. You've got species extinctions. So here I want to pause a bit just to reflect on what I've said so far. And the Earth has a long history. It has experienced much more extreme conditions than what we've got going on now. Humans are among the causes of climate change. The Earth really doesn't care how high sea level is or other problems that we might bring to it. So the Earth can endure, but we're going to have real problems, humans, with sea level rise if sea level continues to rise, because we've got so much built along the coasts. When sea level rose fast at the end of the last ice age, humans could pick up their few belongings, walk a few miles inland, and there'd be no problem. We can't do that any longer. But the models aren't perfect. They could be wrong. And if people ask me, am I sure the models are correct? My answer is absolutely no. I am not sure they're correct. In fact, I know that they're imperfect. But they are sophisticated, they are tested, and they are the best means we have at this time for predicting future climate. So now I'm going to list my three major categories of concerns regarding how the messaging about climate change is often presented. And first concern is that at times it's just not presented accurately and in a balanced way. And my previous half hour discusses that one bullet, the fact that big errors are being made, very false statements are coming out. My second one is very different. My second bullet is that there's a huge mismatch between lifestyle and message. And this comes out most prominently when one thinks about travel. There are people who claim that the climate change issue is the biggest issue facing humanity today, and yet they are traveling so much that their carbon footprint is among the highest in the world. And this is just not a good message. And I put a picture up of from 1963, Birmingham, civil rights protesters being hosed down, violently hosed down, because this illustrates this huge contrast. I grew up during the civil rights movement. I regard it as the most important cause I've ever been involved in. During the civil rights movement, people gave up their jobs, they gave up their time, they gave up, some gave up their lives. Many went to jail. I went to jail. It was a time when people were really dedicated to the cause. And now people with climate change issues, some of them won't even give up some travel time. And to me, that's a problem. That's a problem, mismatch between lifestyle and message. And I know some of them really do try hard, but I just feel that the mismatch is a problem when you're trying to give a message. Your lifestyle should correspond better. And then there's also, in the discussion of climate change, both sides, if you want to call them sides, those in the mainstream, those not in the mainstream, both have gotten very nasty toward each other. And I think that's another mistake. It becomes not a scientific discussion, but instead a nasty confrontation, which is really, really unfortunate. So my suggestions to people in the mainstream would be, first, present the case accurately without the exaggeration. Second, as much as feasible, match your lifestyle with your message. And that means limiting travel, limiting heating and air conditioning, unless you use clean energy sources. Reduce, reuse, recycle. There are lots of travel that you could do that don't cause greenhouse emissions. You can walk, you can bicycle, you can kayak, you can rowboat, sailboat, skateboard, roller skate. So there are lots of ways of getting around. And I'm not an extremist on this, but I just say, pay attention to your greenhouse gas emissions and try to limit without going to the extreme. And then the third main bullet here, forego attacking people who disagree. Try to keep the discussion as civil as you can. And so here are some explicit examples of recommended improved phrasing. Don't say all glaciers are retreating. Instead, many of the world's glaciers are retreating, or of the glaciers with good records, by far the majority are retreating. And I know I'm running out of time, so I won't go through the next two examples, but I do want to mention the last one, because when people hold up a placard saying "Stop climate change," that's just so troublesome in terms of just being so unrealistic. You could still have a punchy placard, almost as short, by saying "Stop damaging our climate." I mean, that's just as strong a statement. It's just as powerful, and it doesn't have the problem of ignorance of climate change is, a 4.5 billion-year history behind it. So last two slides, a summary. Rachel, Carson, and others presented concerns about the environment in ways that led to effective responses, legislative and otherwise. Advocates for legislation to reduce human impacts on climate change have been less successful. The Earth has a long and fascinating history, and humans are among the causes of climate change now, but there are many others also. The case for reducing emissions is strong. the models are imperfect, but they are sophisticated, they are tested, and they are the best predictors we have. And my advice on messaging: present the case accurately, match lifestyle with message, and be civil. So for those who want one single key takeaway message from my talk, this would be the message I'd like them to take away: that we should limit our emissions, not because we are certain about the future, because we aren't, but because we should heed the warnings of the best models we have. And then at the bottom, I've got what I think of as a key illustrative point that kind of encapsulates a lot of important facts. And that is, the Earth doesn't care how high sea level is, but it sure matters to humans at this point. So that encapsulates that the Earth has experienced way different sea levels, but humans have built so much along the coasts that it really does matter to humans, but not to the Earth. So at that, I will stop sharing.
Well, thank you so much, Dr. Parkinson, for your fantastic talk. Very stimulating, very informative, and also very useful suggestions in terms of the messaging. Now it's time for questions. The audience again is encouraged to put questions in the Q&A boxes. And now I see already there is a question there already. So you want to read that question and then answer?
Okay, thank you, Jack.
Yeah.
So the question is, the media wants their articles read, so they often inflate interpretations from scientific publications. As a scientist, how do you ensure that media coverage of your research is accurately represented? That's a great question, and it addresses a very important issue. And I do think that part of the problem with the misstatements being said is that the media wants the strong statements. So like the questioner says, the media wants their articles read, so they want the strong, punchy statements. They want somebody to say, a disaster's coming, or the opposite. They don't want somebody to have a middle position. So my feeling in terms of what a scientist should do is, just when they're interviewed by the media, don't fall into the trap of giving the strong statement that's inaccurate. Try to make the statement accurate, even though you might have to force it to be really brief, because that's what the media wants. So I would say, when interviewed by the media, just try to keep accuracy forefront in your mind, even though you're going to also have to be brief.
Yeah, great. Thank you. There is another question there now. Okay.
Okay, the next one is, what are the other vital roles scientists can play in addition to messaging? Well, certainly a prime role for scientists is to get the data and to present it in a way that's understandable. And getting the data often does mean traveling. So as I said, I'm not an extremist on the travel. I just say limit the travel when you can. But getting the data, and you can get the data by ice cores, deep sea cores, tree rings, satellite data. The satellite data has the plus of not requiring the person to travel to get it. But so I'd say getting the data and then analyzing it, writing it up, both for scientific journals and also in a form that's understandable to non-scientists. And then speaking, like to groups that might have an interest. Okay, and then the next question is, I hope this isn't too forward, but all academic scientists should consider asking their college's communication teams for help making the balanced science sound punchy in the quotes you give media. We would love to help your points make an impact in the media, and many of us have worked in media, but now work in academia. We love science and okay, because we love science and important issues like climate change. Well, that's a wonderful message, and that's fantastic. I'm very, very pleased that the college's communication teams want to help and are hopefully something like the punchy change from stop climate change to stop damaging our climate. Hopefully that punchy message can be the type of message that the communication teams will end up liking.
Great. I have a question here. You mentioned that historically, carbon concentration actually was higher than what we have now or in the foreseeable future. Then some people may wonder why it's necessary to reduce carbon emission now and in the future.
Okay, so the difference is that now we and other species have adjusted to the climate that exists now and the sea levels that exist now. So the Earth wouldn't care if the carbon dioxide amounts got way, way, way higher. However, if they do get way higher, we can expect further warming, further decay of the ice sheets, further carbon dioxide into the oceans, which is going to increase the acid amount in the oceans. And ocean acidification is a big problem for some species of marine animals and plants. So the reason that it's helpful not to keep increasing carbon dioxide is because of human infrastructure, not because of the Earth itself. The Earth can take it. So, but humans have built so much up along the coasts. Islands are and whole nations are expected to be underwater within decades. It's a real problem for people along the coasts.
Yeah, so thank you. That's great. You also mentioned lifestyle and lifestyle mismatch between the action and needed and the lifestyle some people have. And there are a lot of lifestyle change, for example, in like a household arrangement. In the past, we focus on population size, and now a lot of countries actually have declining population growth rate. And for example, in China, the government encouraged people to have one child, and in the last several decades, but in the recent years, in China, actually trying to encourage people to have more babies, like three, and from one to three. And how do you view this kind of policy shift
Uh,
from one direction and then to another direction?
that's actually excellent point. The population issue, when I was growing up, was indeed claimed by some people as being the major issue. And so I and others were encouraged, don't have children, or at the most have one or two. And now it's just not like that at all. And you mentioned China, but also Italy, Russia, Japan, all those countries are having huge problems now keeping their populations stabilized and not decreasing. So that's illustrative also of part of the reason why what seems to be the most crucial issue at one point, like in the 1960s, population explosion was considered a huge problem. And now it's climate change that a lot of people consider a huge problem. So, I mean, fortunately, some of, like your comment about the Chinese, their one-child policy, cruel as it might have been in many, many respects, did reduce their population. It did have a huge benefit in terms of reducing their huge population. And with the climate change issue, maybe all the concern about climate change will have the desired effect of reducing emissions. And so, I mean, it could be a few decades from now, people are back to worrying about a coming ice age because maybe just like the population reversing the issue, maybe it'll happen the same way with climate change being reversed. But right now, it's the concern seems to be more in the direction of limit our emissions.
Great. Thank you so much. We run out of time, so we will stop here. So thank you so much again for your wonderful presentation and excellent answers to the questions. And also thanks to the audience for participating in this lecture. And goodbye, everyone, and enjoy the rest of the day or evening, depending where you are. So thank you so much, everyone. Yeah.
Thanks, Jack.
Yeah.